What's going on, you guys? Mr. Allen here. We have ourselves a lovely problem here. Given f of x equals that polynomial right there and its graph, write the function in factored form across a set of all real numbers. So all real numbers, no imaginary numbers, right? Otherwise, it would say across a set of all complex numbers, and we would include the imaginaries, and then it gets a little cray, man. But here, just real numbers. So I have a y-intercept of 0, comma, negative 12, which agrees with this guy right here. If I plugged in 0, I'd be left with negative 12. That's my y-intercept. It's not really helpful, though, in writing it in factored form. What is helpful would be my x-intercept of positive 2. So that means that there's a factor of x minus 2, and that would get me my x equals positive 2. So how could I use that to figure out the rest of this? Well, perhaps I could divide that factor out, or divide that 0 out of the function right there, and that would leave me with another piece to work with, right? It would be a quadratic that it would leave me with, right, if I divide out a linear factor right there. So let's go ahead and divide that out. I'm going to use synthetic division on this one because it's x equals positive 2. Real easy to work with synthetic. So I'm going to have 2 right there. All my coefficients. Boom. Lovely. Draw my line. All right, we're going to drop that 1. We got 2 times 1 is positive 2. Add them, we get 4. 2 times 4 is 8. Add them, I get 6. 2 times 6 is 12. Add them, we get 0. That's my remainder right there. That's important, guys. If I got something other than 0, I know I did something wrong because I know that my 0 is x equals 2, right? It's got to divide out clean if it's a 0, and it is on that graph. So if it was not 0, I'd have to go back and check for an error, right? Okay, so let's continue here. We got ourselves the constant here. We got our x and we got our x squared, meaning we have x squared plus 4x plus 6. That's what's left over here. Can we factor that? Well, nothing multiplies to 6 and adds to 4. Also, we can clearly see this thing is a cubic function. It's going down here. It ain't coming back up and hitting that x-axis. So this means we're going to have two imaginary solutions here for my zeros, and I'm not going to be able to factor that thing across a set of all reals if, right, they're going to be imaginary solutions. So that's it for this. So here's what I'm going to do is I'm going to throw that guy right there, right? And then I'm going to jot down my little f of x right there, f of x. And I'm going to throw in this guy as a factor, so that's going to be x minus 2, as we said earlier. And boom, diggity. This bad boy is in factored form across the set of all reals. We cannot continue factoring that quadratic. It is not factorable, bro. As much as I wanted to continue factoring, we can't, right? But it does make sense. One real solution. We're going to have 2 complex solutions, as you can see by this graph still going down. That's dope. That's awesome. You guys are dope. You guys are awesome. And I hope you guys are loving that math. See ya.